Tech Talk Tuesday.
Hey, this is Will with SRT Amplification, and this week is going to be an early episode of Tech Talk Tuesday. I've got some family coming in this week, and I'm going to get this out a little bit early, so you'll probably see it on Monday instead of Tuesday. But today I wanted to talk a little bit about capacitors and markings on capacitors and the values of capacitors and how that translates to what you see in a schematic or what you see inside of an actual circuit, and then what's actually marked on a capacitor. So one of the things that I've noticed that a lot of people struggle with is how to convert between, microfarads, picofarads, all the different prefixes in the metric system, and then actually what they're actually seeing on the schematic. So I've got a few tips I'm going to share with you on how I do it, and if it helps you out, then that's great. If it doesn't, if you got a different way of doing it, please let me know in the comments, and we'll share it with everybody. But this is the way I do it, and it seems to be kind of a simple and a way to keep it straight in my head anyway, and maybe to help you guys too. So let's look at some of these things. One of the first things that we have to look at and to kind of familiarize ourselves with is how we come up with the different prefixes for the values that we're talking about, whether we're talking about henries or ohms or farads or amps or whatever. Basically, in the metric system, everything is based off of 10. It's a base 10 system. So you have exponents of 10, whether it's 10 to the first power, 10 to the negative first power, whatever. Basically, that number that is the exponent is how many zeros forward or backward the decimal point's going to go, or how many spaces the decimal point's going to go. So when we're talking about farads is a value of capacitance, and it's a very small value. So your typical capacitance values are going to be usually in at least the micro range, and more than likely, a lot of them are going to be down in the pico range, which is if you could look at this chart here, the micro is 10 to the negative 6. So that means basically if we start at 1 and we go down towards, so if we start at 1 right here, what would be 1, and we count back 6 spaces, that's where our decimal lines. Or you could look at it like this: if you count 6 spaces this way, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, we'll wind back up at 1. So it's 1/millionth basically of 1. So that's why the 6 decimal places. Pico, on the other hand, is 1/trillionth, or 10 to the negative 12th. Or another way of looking at that is 1/millionth. And you'll actually see some values either on schematics, or I've even seen it on capacitors themselves, that'll say micro, which would be the same as 1/millionth. So if you can wrap your head around this, basically what you're going to be doing is working between micro and pico, because that's where the values are going to be on most capacitors. So what you need to do is realize that there's a 6 decimal place difference between micro and pico. So if somebody says that I have, 1 pico farad, which would be out here, all I need to know is I need to go 6 spaces this way, 1, 2, 3, 4, 5, 6, and it would be 0.0000001 microfarad. So I'm basically just moving 6 decimal places. Hardly ever do you see nano. They do have capacitors that are in the milli range, but they're very rare too, especially working with amplifier circuits and stuff like that. You're not going to run into those too much. All right, so let's look at some capacitors real quick, on the actual capacitors themselves, and see the markings on those.
So here we're looking at some old paper and wax style capacitors. And if you'll notice on the value, they use the abbreviation capital MFD. And at this time, this was their annotation for microfarads. I've been told that they used this because the equipment that they used at the time, we're talking, 60s, 50s, 60s, 40s, even 30s, did not have the ability to reproduce or to type or print the Greek letter mu, which we use as a symbol for micro. So in this instance, they used MFD, which is just kind of an abbreviation for microfarad. They couldn't use the lowercase m because that might be confused with a millifarad, although I've never really seen any capacitors or schematics label capacitance in millifarads. There's a possibility that it could. But if you also remember from our chart, the capital M is the prefix that we use for mega. And so I guess that they assumed that people would not confuse the big M for mega, because that would be a very, very large capacitance in a component to have. And maybe somebody's built a capacitor with that much capacitance, but if they did, it's probably not something that the consumer is going to be using. So in this instance, if you see one of these old style capacitors in any vintage gear, this MFD is microfarad. So the one on the top would be 0.1 microfarad, and the one on the bottom would be 0.05 microfarad. So let's look at a modern day capacitor. Okay, these three capacitors are modern day polypropylene foil type capacitors, used in a lot tone circuits, coupling caps, etc. They're non-electrolytic, non-polarized capacitors. For these types of capacitors, the value is kind of coded into them. And if you look at the top of each one of them, starting on the left, you have a 224K, a 683K, and a 104K. What confuses a lot of people is the K. The K is not a multiplier. It doesn't mean 1,000, anything like that. The K is actually a letter designation for the tolerance of this capacitor. K being 10% tolerance. You'll also find common J, the letter J, which is a 5% tolerance. But there's pretty much all different kinds of tolerances, and they just use letter designations for those. You have to look it up on a chart. But normally you'll find J's and K's, 5% and 10% tolerances. As for the value of these capacitors, we have to look at a chart in order to learn how they use this coding. And then once you know how the coding goes, you can just look at a capacitor and tell what the value is with a little a little manipulation. So let's look at that chart right now. A chart that gives codes, common codes for capacitors. But once you understand how this works, you really won't need to look at the chart. But just know that there is a chart you can look at if you want to reference it each time. So our first capacitor in the picture had the code of 224, and I've circled it here on the chart. Basically, the 224 is, the way I look at it, is 2